Hello, my name is Simon Graham. I'm the architect for provisioning at Citrix, and today I'm going to talk to you about using PVS in Azure. So we're going to have a little introduction to why would we want to run PVS on Azure, some slides on the architecture and background for how we came up with this, a quick demo for showing creating PVS targets in Azure at scale, and then a summary. So why do we want to run PVS in Azure? Well, three main reasons. One is image management. You're probably all familiar with PVS on-premise. It allows you to have a single image for all target VMs. You update the image in one place, and all the VMs using it will be updated immediately. It's very easy to update and roll back. There's no need to re-provision VMs to change the image. You just reboot them. Similarly for rollback, if a problem happens, you can change the VMs back to the previous version and then just reboot them. And the last thing is that a sort of canary process is very easy for you to set up. You can update individual targets to a new version and let people test those out first without re-provisioning, without creating a new catalog, just some VMs in the same catalog. The second major reason is cost management. So the reduced cost for storage here, because with PVS, you only have a single copy of the image. And lastly is performance, particularly the time to reboot non-persistent VMs is less with PVS because there's no need to recreate the boot disk, re-provision the VM in order to set it back to the golden image. Every time you reboot a PVS target, it starts off running the golden image again. And also PVS is optimized for delivering boot disk contents. So there's some background here. When we started this project, fundamental goal was to provide the same experience as you have with on-premise PVS. So that there's no need to learn a new tool or a new product. You don't need to update your procedures or retrain the admins. You configure the PVS infrastructure in Azure the same way as you do on-premise. So just like on-premise, there is a PVS server or servers that stream the operating system from a single copy of a virtual disk to all the VMs. Those VMs, those target VMs, are created by us with a very small boot disk and a cache disk to capture any writes that are made whilst the VM is running. Those target VMs are added to a broker catalog and power managed by the CVAD broker, just like on-premise. And again, just like in a data center on-premise, the customer is responsible for setting up the infrastructure. So the connection back to an on-premise network if required via an express route, configuring your Azure networking within your Azure subscription, and then installing the PVS infrastructure, PVS servers, and so on within that environment. So this picture tries to show, in summary, the way this is done. So in the center, you'll see the customer subscription, which is where PVS runs. And in there you would have PVS servers, more than one, to provide HA and scalability. Those PVS servers have access to virtual disks, either locally on the PVS server or via a share. Azure Files is supported, as is Azure NetApp Files. It uses a SQL database, and in the GA product, this can be either an Azure SQL instance or it can be a SQL Server VM that you create yourself. You would have a domain controller, so PVS in Azure supports classic AD only at this point in time. So typically you'd want to have a domain controller in your subscription that is connected to your on-premise forest through the express route. Just like, you also have a license server. So today you need to have the same sort of license server as you have on-premise today. In the future, we will move to using cloud licensing, and that's not done yet. So just like on-premise, you create the vDisk from a master VM that you set up exactly as you want the image to be first. You use imaging tools to send that data to the PVS server and store it in a vDisk. And then all of the target VMs are set up with this tiny boot disk, it's 1 gigabyte, and a cache disk that is used to cache any writes. And then at runtime, those target VMs, when they boot using that boot disk. That gives them enough information to talk to the PVS server and start streaming the operating system disk from the vDisk, just like on-premise. Any writes that happen while that VM is running end up cached in RAM first, and then that overflows to the cache disk. Again, just like the on-premise, existing on-premise. And those target VMs are added to a broker catalog in Citrix Cloud. That broker catalog is part of a delivery group, just like any other setup, and that delivery group can support things like auto-scale and so on to power on and off the target VMs as they're needed. What do you have to do to use this? Well, there's a few things you have to set up in order to use it. First of all, Microsoft have made some changes to Azure to support PVS, specifically to allow networking at boot time, so that we can do a boot time connection to the PVS server. In order to use that, you need to enable a feature on your subscription called Reserve Mac on Create NIC. This feature doesn't really make a lot of change. It just means that when a virtual NIC is created in Azure, Azure will allocate a MAC address for it at that time instead of the first time the VM boots. And this is needed for PVS because we need to know the MAC address in order to know what the target is and what it should be running. You need to create your resource groups and your virtual networks. There's a current limitation of 2,500 VMs per subscription. It's the same limit as MCS, and it will expand as MCS expands. But what that means is for large deployments, you'd need multiple subscriptions, and we do support multiple subscriptions. We would recommend using a standard hub and spoke configuration of virtual networks to connect them all together and to ensure that all the targets can talk to all the PVS servers and domain controllers and all the other application-specific systems they need to connect to. You have to configure your ExpressRoute connection to the on-premise network if you want to continue to use your on-premise forest. And like I said, PVS requires classic AD. We do actually support either sort of a native Active Directory domain controller VM in Azure or Azure AD Domain Services, which provides an AD front end on Azure AD, a classic AD front end. Once that's in place, you have to create your infrastructure VMs. So you do need to have CVAD cloud connectors to talk to CVAD service. This is exactly the same as any other use of CVAD service. You need to configure your Azure SQL services or install a SQL Server instance VM yourself. You can use your on-premise license server, but you can also create a separate license server VM within your Azure subscription, which is probably better from an availability point of view, because it's still there when the connection back to the on-premise data center is down. And of course, you need to create your PVS server VMs, and you need at least 2 for every 2,500 targets. We recommend a minimum of 4 CPU and 16 gig of memory for those PVS servers, and also that you should enable accelerated networking on those servers so that we can get the larger throughput when target VMs are booting. Having created the infrastructure, of course, now you have to use it. So just like on-premise, you would create a master VM and set up the disk on it and the vDisk, just as you would on-premise. So create a master VM, install operating system from the marketplace or from an image you already have, and then use the imaging wizard to turn that into a vDisk. I should note that we only support Gen 2 Azure VMs, which you can select in the advanced properties in the Azure portal. And this is an absolute, and you won't be able to install the PVS target drivers if it's not a Gen 2 VM. Once you've created the virtual disk, then you want to provision the target VMs, and we recommend using the CVAD setup wizard because that takes care of all of the steps required. It creates and uploads a bootable disk containing the PVS UEFI boot program and metadata that allows the target VMs to contact the PVS server. We create target VMs as Gen 2 VMs with that disk as the boot disk and with an additional cache disk. The setup wizard boots the VMs one time in order to allow them to format this cache disk as an NTFS disk, and then shuts them down and deallocates them. And lastly, VMs are added to the PVS target database in the PVS server and also a broker catalog. And once that's done, you're now ready to start using them. You can power manage the target VMs using the broker power management, which provides automatic control of PVS targets in Azure. You can, of course, use the PVS console to do this as well, to manually power manage targets. But normally you want broker in charge of that because it knows what targets need to be running in order to let clients connect. Now I'm going to show a quick demo of running the setup wizard. Now we're going to show creating a bunch of target devices in one go with Citrix Virtual Desktop Setup Wizard. First thing we have to do is enter some parameters to connect the CVAD service, specify the connection to Azure we're going to use, and pick a VM template to use for all of the targets we're going to create. Identify the catalog, and now we're going to create 500 targets here in one go. Pick a resource group to put them in. Create some AD accounts with these target VMs. Specify the PVS servers that are going to handle it, and then we're ready to go. And we hit finish at around 2 minutes and 40 seconds here. First step is to create and upload the boot disk that all of these machines will use. And once that's done, we will start creating the 500 VMs. I'm going to speed things up a bit here. Don't need to wait for all of this. And you can see on the left-hand side here, looking at the Azure resource group in the portal, a whole bunch of resources are created. There should be 2001 resources when it's done. Virtual machine, NIC, 2 disks for each VM, and the boot image that each of them is going to use. So all 500 desktops have been created. We have some final cleanup to do here. And then at around 20 minutes and 20 seconds it will be complete, which translates to around 2 seconds per VM. And we can see that the collection exists in the PVS console and also the resources are there. And there we are, we've created 500 target VMs. So in summary, PVS on Azure gives you a really good way to provision and manage targets at scale. The boot times for those PVS stream VMs are around 40 to 60 seconds, which is a pretty good time. It provides the simplified image management that you're used to running on premise, so that versioning and rollback is instantaneous. And it will reduce your storage costs in the cloud because it's a single copy of the image. Now, each of the target VMs has a cache disk, but that's usually around 25 to 50% of the size of the image, giving you immediate savings. Thank you.